nucleus, cytoplasm, and plasma membrane from what's called the neurolemma. Okay? And inside the neurolemma, we have layer after layer after layer of myelin. We have the myelin sheath.
Yeah, we couldn't figure out what the neurolemma was.
Well, so again, the neurolemma is the Schwann cell, all the Schwann cell outside the myelin sheath, not including the myelin sheath. Okay. So we have what kind of a neuron is this?
Multipolar.
This is multipolar. So we have the cell body with dendrites. These are dendrites. There's the axon. Axons in section, axon continuing right there. So definitely more than two processes coming off the cell body. Definitely cell body. Whoops, well I was going to say because there's the nucleus, but it's not showing the nucleus. So if these are dendrites, what the heck are these things? Well, actually, this is the axon terminal. See this bulge? This is the axon terminal or synaptic end bulb or presynaptic terminal. This is where the neurotransmitter containing vesicles are packed. In fact, this particular axon terminal is cut open to show the little yellow vesicles inside containing the neurotransmitter molecules right in here. Okay. So cell body, dendrite, axon terminal of a totally different neuron, teledendron, of a totally different neuron, axon terminal, teledendron. So there's another neuron coming in, leading to the neuron lying on the board here. So if we followed this particular neuron to its logical conclusion, obviously it got chopped off here, you would come down to its teledendria and axon terminals at the very end. So instead of making a model that's 100 feet long, which would be to scale, they had to chop it off here, and to compensate, they put in teledendria and axon terminals of another neuron leading to this particular neuron. Now, notice that they're actually attached. In real life, they're not attached. There's a tiny, tiny gap in here called a synaptic cleft. There'll be a little space in here called a synaptic cleft. But there's no way they could have it hovering in midair, so they had to glue it on. Okay, dendritic zone. Cell body plus dendrites. That's the dendritic zone. And you notice the dendritic zone has receptors for the neurotransmitter molecules. So you would have neurotransmitters being released on the cell body receptors, on the cell body receptors, on the dendrite receptors, onto dendrite receptors, and so on. And here is the axon hillock. So you've got neurotransmitter molecules being released onto the axon hillock, which is cell body. Then we come to the initial segment of the axon. No more neurotransmitter receptors. Totally different deal as far as the neuron is concerned. We have moved on from the part of the neuron with neurotransmitter receptors onto a totally different part of the neuron. The axon has no neurotransmitter receptors. So initial segment of the axon, section axon in here, showing the axoplasm, there's a mitochondrion, there's another, etc. Axon continuing, and axon in cross-section. Also showing the layers of myelin, the myelin sheath, and the Schwann cell nucleus here. This thing is called there we go. This thing is called the endoneurium. It's a layer of connective tissue. It's the innermost layer of connective tissue in the nervous system. So it would wrap all of these Schwann cells all the way up here. So they've cut away most of it to reveal what it's surrounding here. Okay, Schwann cell, here's one from here to here. Here's another from here to here. And here's part of the third. Myelin sheath on the inside directly around the axon. There's a second Schwann cell. Here's its myelin sheath around this portion of the axon. So each region of the axon gets its own myelin sheath, gets its own myelin sheath, gets its own myelin sheath, except for the gaps between the Schwann cells. Node of Ranvier. Node of Ranvier. So there's a little bit of axon in here, has no myelin sheath around it. There's a little bit of axon in here, no myelin sheath around it. Naked axon. In Unit 2, we'll get into the significance of that. Having the axon myelinated versus unmyelinated. So this unmyelinated, myelinated, 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 The teledendria are not myelinated. The axon terminals are not myelinated. And of course the cell body and dendrites are not myelinated. So all those unmyelinated bits, this would be part of gray matter, this would be part of white matter, where you've got the myelin. What else? That's pretty much it. Number